Hello, I welcome you all. The problem reads, determine the velocity of the 60 pounds block A if the two blocks are released from rest and the 40 pounds block B moves 2 feet up the incline. The coefficient of kinetic friction between both blocks and the incline planes is 0.1. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. We're going to use both the kinematics as well as the principles of work and energy to solve this particular problem. So let's begin. Okay, so I have references there for this position like so. Okay, there we go. Alright, and let's say going down like so, being our reference. We do have the other one there like so. Okay, they are like so. And then we have the weight acting through the center of gravity. Let's say this is the weight there like so. And then we have components in this direction like so, one in this direction like so, and another one in that direction like so. Then we do have another component like so. Okay. Another one in that direction like so, and another one like so. Alright, so let's say we have the normal force there like so, and since A tends to move, we've been told block B moves up, therefore A moves down, therefore we have friction like so. Okay, in this one we are going to have normal force like so, and this tends to move up, therefore we'll have friction like so to oppose motion. Okay, what else? So the angles, so this one there, if this is this is theta, this is 60, this becomes 30, and this will be 60. Okay, so this one here is 60, and the same that side. Let's get there, we do the same. Let's say we have something like so there. So if that is 30, if this is 30 here, this becomes 60, and this one is 30. Alright, let's plug it in. So this one here is 30. So this one here is W. This is W. Okay. This is W. This is WB. And this one here is WA. Okay. This is the normal force A. And this one is the friction force A. Then we do have components. This is WA sine 60. This is WA cos 60. This one is WAB cos 30. This is WB sine 30. This is the normal force normal force B, and this is the friction force B. This is SB, and this one is SA. And then let's say we show the direction of movement. Let's say this goes up, and then this one goes down. So we said this one we are going to call it as, we'll call it as HB. This one we'll call it as HA, the one going down. So let's write down the equations, the kinematic equations. So we'll have 2SA plus SB equal to the total length. The change in A plus the change in B, this is equal to 0. And then the derivative of this SA, the position, gives us 2VA plus VB equal to 0. We can end here for now, because we know that if we have VA like so, and VA we are saying is going, VA is going down, therefore our VB is just going to be equal to 2VA, and this is going to be going up. And we do also have this here, and we said our delta B is just going to be equal to, we've been told it moves up, right? Moves up by 2 feet, which is up, and therefore our delta A is just going to be equal to delta B divided by 2, which is just going to be equal to 1. Alright, and this is moving down. Alright, so we have written everything. Let's find the values of these friction forces. We need them before we apply the work and energy principle. So let's start with block A. Block A, so we'll say summation of forces in the Y just equal to MAY, but we know that our AY is just equal to 0. I is our A, so this just gives us NA minus WA cos 60, okay, equal to 0. Therefore our NA is just equal to WA cos 60, and our FA, which is our friction force, is just equal to mu K NA, which is just equal to 0.2 by WA cos 60. Then for block B, we do have summation of forces in the Y equal to MAAY, but we also know to say our AY here is also equal to 0. So what do we have? We do have NB minus WB cos 30 equal to 0. Therefore our NB is just equal to WB cos 30, and therefore our FB is just equal to mu K NB, which is just equal to 0.1. Is 0.1, right? Sorry, even here it is 0.1. Where did the 0.2 come from? This is 0.1. This is 0.1 WB cos 30. So we have all the information that we need, and then the initial kinetic energy, okay, plus the total work from point 1 to point 2, this is equal to the final kinetic energy. Okay, right? So this is being released from rest, therefore it means this is 0 cause it is being it is released from rest. All right, let's go on up there. I just create some boundary so that we can work out these equations so that we solve them. Okay, there we go. All right, so we do have 0 there plus 0 like we said, and then what else do we have? So we have we start with A. So HA is going in the same direction with WA sine theta, sine theta, which is 60 degrees there for positive work. So say WA sine 60 times HA. Then in the other case, we have negative HB is going in the opposite direction with W sine 30. So we'll have WB sine 30 times HB. And then work due to the friction forces. Let's start with A. FA, that's negative. They're all going in the opposite direction. So that will be FA times HA. The same applies to B, it's in the opposite direction, FB, the friction force times HB. Right, and then this is equal to the kinetic energy final for both blocks. So we have half MA VA squared plus MB VB squared. Alright, we know that our VB is just equal to 2 our VB is equal to 2VA. So if we were to write this, it just becomes equal to factoring out VA squared. This is equal to, that's WA sine 60 HA minus WB sine 30 HB. And then this we have our FA there, which is the friction force, 0.1 WA cos 60 times HA minus 0.1 if I move this just a little bit there like so, okay, 0.1 WB cos 30 by HB. Okay, maybe I move this a little bit again, just a little bit. Right, and also this one I move it maybe there like so. Okay, then I divide everything. Maybe this I'll need to just create more space here. Let me create more space. It's like space is lacking. Okay, right, there we go. So this may be our VA. Our VA maybe should be somewhere there. Okay, our VA squared, this is squared, this should be somewhere there. Okay, so divided by 0.5, 0.5 by MA, and plus 0.5 by MB by 4. Okay, we said BB is equal to 2A, right? Like so. And also this is 1 like so. Okay, so our WA, we know that, given that, WA is equal to 60 pounds and WB is equal to 40, and then MA is equal to 60 over 32.2, and MB is equal to 40 divided by 32.2. What else? Of course, we know that our HA is equal to 1. Okay, because we know that this HA is equal to delta B divided by 2, which is just equal to 1, and HB is equal to delta B, which is equal to 2. What else? I think we have included everything. Therefore, making VA subject to formula, don't forget to square, to take the root. Okay, I did both numbers because it's a little bit long. So WA, that's 60 sine 60 times 1, minus WB is a 2 by 40 sine 30, then minus 0.1 by 60 cos 60, okay, by 1, then minus 0.1 by 2 by 40 cos 30. Okay, then we divide that, and we multiply that, then we divide it by 0.5 by 60 divided by 32.2 plus 0.5 by 40 divided by 32.2 by 4. Okay, then later on square root of that, then we find that our VA is just a 7715. Okay, then working out our VB, which we can work out from this, we can pick one of the equations here, and this is how they are related. You've seen here. Okay, right, that's how they are related. So 2VA is equal to VB, therefore VB will just be double of that. Okay, so VB just gives us a 1.5430. This is feet per second, this is feet per second. Alright, this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.